When you delete a photo from your phone, where does it go? When you burn a letter, what happens to the words? Most people would say it's gone forever, destroyed, erased from existence. But physics tells us something both fascinating and deeply unsettling. Information can never truly be destroyed. The universe remembers everything. Every single thing you've ever done. This isn't philosophy. This isn't spirituality. This is one of the most fundamental laws of quantum mechanics, and it has led to one of the biggest fights in the history of physics. A battle between two giants of science that lasted decades. The information paradox. In the quantum world, information cannot be created or destroyed. This concept comes from two fundamental theorems of quantum mechanics called the no-cloning theorem and the no-deleting theorem. But there's a third theorem that takes this even further, the no-hiding theorem. According to this principle, if information disappears from one system, it simply moves somewhere else in the universe. It cannot be hidden, it cannot be erased, it's just residing in a different place. Think about burning a book. You watch the pages curl and blacken, the smoke rises, the ashes scatter. Common sense tells you the information in that book is gone forever, but physics sees something completely different. In principle, that burned book is just as readable as the original. If you could analyze every particle of ash, every molecule of smoke, every photon of light released by the flames, you could theoretically reconstruct every single word. The information hasn't been destroyed, it has been transformed into a form that is practically impossible to retrieve, but it's still there, somewhere in the universe. This is called the unitarity principle. It says the universe is reversible. What's done can always be undone. If you know everything about the cosmos in the present, you should be able to rewind it and understand everything about the past, and predict everything about the future. Knowledge is always preserved, but then came Stephen Hawking, and he broke everything. In 1974, Hawking shook up the entire world of physics by showing that black holes aren't eternally stable. They actually radiate energy and slowly evaporate over time. This radiation is now called Hawking radiation in his honor. But here's where the paradox begins. When something falls into a black hole, all its information gets trapped inside. The mass, the energy, the quantum properties of every particle. Everything gets encoded onto the surface of the black hole. But Hawking's calculations showed that when a black hole evaporates, the radiation it emits is completely random. It contains no information about what fell inside. So what happens to the information? Does it get destroyed when the black hole finally vanishes? If it does, then the fundamental law of physics is wrong. Information can be destroyed, but if it doesn't, then where does it go? This question haunted physicists for nearly 50 years. Hawking himself believed information was destroyed. He even made a famous bet with other physicists about it. The implications were terrifying. If information could be lost, then the laws of quantum mechanics would break down. The universe would become unpredictable at its most fundamental level. In 2011, scientists finally tested the no-hiding theorem experimentally using nuclear magnetic resonance devices. They proved that when information seems to disappear from a quantum system, it actually transfers to the surrounding environment. It doesn't hide, it doesn't vanish, it moves. But the black hole problem remained unsolved until recently. In 2019, researchers made a breakthrough discovery. They found that black holes might contain special regions deep inside called islands. These islands are strange. They're part of the black hole, but also not. In a weird way, they exist both inside and outside the black hole at the same time. As the black hole evaporates, these islands escape with the radiation, carrying the information with them. New research from UC Berkeley suggests that for real black holes in our universe, these islands can extend even further beyond the event horizon than previously thought. This means we might eventually be able to detect them. We might be able to prove that information survives. Even more recently, in late 2024, scientists proposed another solution called non-violent non-locality. This takes advantage of quantum entanglement, the spooky connection between particles. In this picture, the space-time around black holes carries tiny perturbations that are correlated with the information inside. When the black hole disappears, the information is preserved in the structure of space-time itself. These signatures might even be detectable in gravitational waves when black holes merge. Stephen Hawking eventually changed his mind. Before he died, he accepted that information probably does escape from black holes. He lost his famous bet, but here's what makes this truly mind-bending for our everyday lives. We live in a universe that never forgets. Not because it's keeping records, but because perfect information erasure is physically impossible. Every event, every decision, every computation leaves its mark on the physical state of the universe. These marks become entangled, transformed, and practically irretrievable, but they're never truly gone. That embarrassing thing you did 10 years ago, the universe still has it stored somewhere. That deleted text message, it's encoded in the particles around you. Every breath you take, every step you make, changes the quantum state of the cosmos in ways that can never be completely undone. The black hole information paradox remains an active field of research in quantum gravity. Scientists are still working out exactly how information escapes, but one thing seems increasingly certain. In the deepest laws of physics, nothing is ever truly forgotten. Universe remembers. Everything. The universe keeps a record of everything. Every moment, every choice, every secret, and science is only beginning to understand how deep this rabbit hole goes. If you want to explore more mind-bending mysteries of physics, paradoxes that challenge everything you think you know about reality, then subscribe to this channel right now. Hit that bell icon so you never miss when we uncover the next secret the universe has been hiding from you, because trust me, what's coming next will blow your mind even more.